Hi all. In this video segment we'll be discussing the binary search tree operations. So we know the property of binary search tree. The left subtree will be having lesser values than the node's value, and the right subtree will be having values which is same or greater than the node's value. This property is followed in the binary search tree. In this video we are going to discuss the operations insertion, deletion and tree traversals performed in a binary search tree. So let us see how the program is written. So in the beginning itself we have to include the needed header files. So for the basic input output operations we need stdio.h, and for the working of malloc function we need stdlib.h. So include those header files. Next we have to define or declare a structure for the nodes of the tree. So we know that a single node will have three parts. The first one is a data part, second one is a left link, and third one is a right link. So we have to define the structure for a node in the tree. So let us do that next. So this is a structure for the node in a tree. It has a data part, it has a left link, that is the link to the left child, and right, star right. This right is a link to the right child of a node. So these are the three fields of a node in a tree. So this is the type def statement, and now onwards you can declare the pointers that is to the different nodes using this node word. So after this statement, node means it is a structure with three parts: data, left and right. Now let us look at the insertion operation in a binary search tree. So while doing the insertion operation we have to keep in mind the principle in the binary search tree. Let's see an example of insertion operation in a binary search tree. These are the numbers to be inserted: 40, 60, 50, 33, 55 and 11. So first insert 40. Since the binary search tree is not present, the first node is 40, so 40 is the root. Next, the element to be inserted is 60. So 60 is compared with the root node, so 60 is more, it is greater than 40, so it should go to the right side. So right child, or there is no right child for this 40, so create a new right child and enter the value as 60. Now next the value to be inserted is 50. So start the comparison from the root node. So 40 is compared with 50, 50 is greater than 40, so obviously the node is to be inserted to the right of 40. Now then to the right of 40 we have the node 60. Now compare 50 with 60. 60 is greater than 50, so 50 should go to the left of 60. So create a new child to the left of 60 and insert the value 50 there. Likewise you have to insert all the other values inside the binary search tree. So whenever an insertion operation is being done, start the comparison from the root node and traverse through the binary search tree to find a place where the node can be inserted. So this is how insertion operation is done in a binary search tree. Now let's see how this is done in C programming. First let us look at the insert operation. We will write a function for the insert operation. So void insert node star pointer int x. X is the value, new value for the new node. Printf enter the new node value, scanf x. So we have to insert a node with value x to the binary search tree. Now if root is equal to null, that means the tree has no nodes. We are going to insert the first node to the tree. So root is equal to get node of x. So this get node of x, this function is used for creating the node and initializing the fields. This is the get node function, node star get node of index, node star temp is equal to node star malloc size of node. After this, the different fields are initialized. The data part is initialized as x, left and right parts as null. Return temp. So the new node created will be returned. So in the first case, in the case of the first node, that is a root. So if root is equal to null, simply create a new node and assign it as root. So root is equal to get node of x. So get node function is nothing but it is a function used for creating a node and initializing the different fields of it. Now assume that we have a node like this. The first node is 40. So if we are inserting the first node, root is equal to get node will be called, and this will be the root. Now in the next insertion, that is if you are inserting a value 20, assume that we are going to insert a value 20. So what should be done? The value 20 is x equal to 20, and 20 will be compared with the value 40. And what should be done? We should create a new node in the left part, that is the left child of this node will be the new node, and the new node will be having the value 20. That is how you will insert a new node if we have to insert a value 20. So that is the case here. While pointer not equal to null, pointer is equal to null root. While pointer not equal to null, if x is less than pointer data, we have to check whether pointer left is equal to null. If pointer is left is equal to null, what we have to do? Pointer's left is equal to get node of x. So what happens? The get node function will create a new node, initialize the data part and left and right parts, and it will return the new node to the left pointer. Pointer left is equal to get node. So we have created a new node and assigned it to the correct position. Now we can make the pointer as null to stop the while loop. Okay. So this is the case when the pointer's left part was null. Now assume a situation like this. That is node 40, to the left there is another node 30. Now if you want to insert 20, what should be done? We should move the pointer to the left child. And now we have to create a new node here, that is to the left of 30. We have to create a new node. So we have to move the pointer to the next node, and if there was another node, you have to move to the pointer to the left or right accordingly. So that is how the pointer is changing. So here, if pointer left was null, you have to create a new node, else go to the left part and continue the search for the correct position where the node is to be inserted. So pointer is equal to pointer left. Similarly, if you wanted to insert a value which was greater than the node's value, okay, pointer is equal to root, and our value was 40. If you wanted to insert a value 50, obviously we have to go to the right child. Okay, so if x was greater than or equal to the pointer data, you have to go to the else part. If pointer's right part was null, you have to make a new node and assign it to the pointer right. Pointer right is equal to get node. This is just creating a new node and assigning to the right part, and after that pointer is equal to null. Else you have to continue our search in the right subtree of the node. So else case, pointer is equal to pointer right, and continue the while loop. So this is the insertion function for binary search tree. While doing the insertion operation, the same principle is followed. That is, the left subtree of a node has values lesser than the node, and right subtree has values greater than or equal to the value in the node. So the same principle is to be followed in the case of insertion operation, search operation, etc. So this is the insertion operation of our binary search tree. If the binary search tree is empty, root is assigned with the new node. Else case, initialize a pointer to root. If pointer is not equal to null, get inside. Check the value with the pointer's value, that is node's value. If it is less, you have to deal with the left subtree, else you have to deal with the right subtree. So this is the insertion function of binary search tree. Next, let us look at the traversals. There are three traversals: pre-order traversal, in-order traversal, and post-order traversal. So in pre-order traversal, we will traverse in an order, that is the node's data, then left, then right. So this pre-order function is written in the form of a recursive function. So pre-order, this is function name. If root not is equal to null, we should print the root's data first, then call the pre-order function for root's left child and call the pre-order function for root's right child. Similarly, for in-order function, the order is different, that is first the left child, then the node's data, then the right child. So accordingly, we can change the order of these statements. And post-order, in post-order we know the root's left and right children are traversed first, and then only the root's data part is displayed. So that is the post-order function. So these are the three traversals of the binary search tree. We can print the values of the nodes in three different orders using these three recursive functions.